to invite you to contribute to the discussion so that we can add our knowledge, and maybe we can have some kind of ideas for the future collaborations. So I wish you a fruitful discussion for this morning. Thank you.
Thank you very much, Dr. Eva, for your speech and opening of this the IPB talk. I'm sorry that your time is limited, Doctor, but I hope we can still continue this and finish on time by 11:30. Thank you, Doctor. Okay, so let's move on to our first speaker. Our first speaker is Professor Baba Barus. And he will talk about the use of GIS and remote sensing for damage assessment of rice fields. Please, Dr. Baba, the time is yours.
Thank you, Ms. Clarissa. Ladies and gentlemen, I'm going to present my activities related to the use of remote sensing and GIS in Indonesia. The content of my talk related to agricultural insurance, where we use remote sensing and GIS to develop new guidance, new method to help government. At the same time, the government also asks our team to continue make new research, and is being conducted now. For your information, agricultural insurance is quite important nowadays in Indonesia, especially to protect farmers who cultivate the paddy. And so far, there are some concern related to the damage due to flood, drought, pest, and disease. And Indonesian government has specific criteria when they want to give insurance to or payment when the farmer fail of their paddy crops, and the method to fulfill the criteria is not easy, since there is shortage of extension officer or staff to report the damage in the field. Then we need to create new method for damage assessment, and basically we develop the method through the research project actually. And Indonesian government now has several activities to support insurance. And
sorry, Professor Baba, can you slideshow the screen?
Yes.
I'm sorry. Yes. Yeah, so we can see clear.
Sorry, the text still some in Indonesia. The current method, basically, the government method use IS to calculate the damage in the field, either due to pest and disease or flood or drought. And of course, after field observation, then they make calculation for the damage and need to pay the insurance. So far, we have problem, especially the shortage of the extension officer or pest observer. Then we introduce new method using drone or satellite. That's the idea. And we create the method actually for the last 4 years. And we just finished it. And when we inform this to the public or the government, there are some expectation for this new method assessment. Especially, we need to introduce this method into at least 11 provinces in Indonesia, and need also to create new model for other important food commodities in Indonesia. So far, we know that we have problem, especially to improve the extension officer or pest observer in the field, because they get used to use the old method. And so far, we already conduct few exercise to transfer the knowledge of our new method to them. We develop guidance especially how to use the remote sensing and GIS, and we produce into software, actually two softwares. One is related to public software, another is a commercial software, and we already distribute all the guidance to all important food agriculture crops in Indonesia. The general process, of course, we develop the basic data, and then taking drone data, make some processing, and create damage index, and then we overlay the damage index with parcel map. Indonesian government calculating the damage based on parcel map. So every result of the method related to the percentage of damage per parcel, actually. We have a problem, of course, to create the proper parcel map, as well as to create the damage index. And there is already standard operation procedure we created. And if you see the right picture, that's the example of the the example of the result of map. We can develop the information whether we can inform per parcel map of the damage idea from 0% until 100%. That's the idea. And Indonesian government has criteria. The payment of the insurance come up when the damage more than 75%. If you see here, there is no actually need to pay to the failure. But we have a lot of problems, especially when we see the damage less than 75%, quite large actually. There is also the information, the way we develop the index of damage for drought, as well as for plant assessment using radar actually. The other things, after we introduce our method and the system and the book, there was the new expectation from the government. What they need is related to detection system, especially to create a model for early warning system for the paddy crop potentially failure. So far, we have a research now. This year, we have the research, and we consider several key indicators related to growth phase, spectral pattern that we developed from field as well as from drone, and the damage status and the wavelength of band we use in drone. So far, what we try to find is related to the model, how to see the gap between normal and abnormal spectral graphic. When we have that kind of method, means we can develop a kind of quite quantitative method to indicate the early warning system that we need. This is the example what we have conducted now. The example of the field method we the data we develop, as well as the image we have. You can see the change of the drone result. Actually, this is the drone result when we try to make a kind of field experiments related to different status of drought or dry status and the damage status. We know that when we have the early stage of growth, quite less damage we found. When we go to the about 70 days after 70 days old already, we have a increased number of damage quite less than 5%, and at the end of the planting session, we have damage related almost 20%. And according to Indonesian regulation, what we consider as important is when we still have the damage less than 5%, then we consider that we have problem when we found the data where the dam is less than 5% in during generative growth. This is the example of our spectral data, and in generative data, we have the pattern of spectral library like this one, and we know this is the example of the abnormal spectral figure. Then we consider this is the source of the model that we want to develop. So far, we know that from our graphic, from our spectral picture, we know we can differentiate the picture, the spectral during vegetative, generative, and ripening is
Ada
quite
orang
different,
apa?
as
Orang
well
Cina.
as
Ini
the abnormal life.
mana ini?
I think that's all what we consider in our research now. So our previous research related to identification of the damage assessment already conducted and now start to be implemented and plan also for socialization the next year. And we have also now tried to develop new early detection method, but still in the early process. And as the government asks, we need to create more model, especially to important food crop in Indonesia. So we are really want to invite you to make a joint research, and you're very welcome. Thank you, Ibu Kalisa. That's all my presentation.
Okay, thank you very much, Professor Baba, for your presentation. Very excellent. We still have 3 more minutes for question and answer. Yeah. Is there any question from the audience?
Shall I close this one?
Yes, you can close, Prof. Baba. Thank you. Any question about the early detection?
Thank you, Professor Barbaros. May I have a question?
Yes.
Thanks for your wonderful presentation. And in your presentation, I found is make use of the drone for the damage assessment, mainly for the paddy crop, right? Mainly for
Yes.
paddy.
Yes.
Because different kinds of damage type have been detected. So could you tell us, take an example, what's the accuracy of the detection?
The accuracy, yeah. You asked about the accuracy. Basically, what we developed in the method, we already test our accuracy. The accuracy more than 90% actually, especially for flood and drought. But for pest and disease, we already finished only for one disease actually. What we called it Howard in BLB. The accuracy around 70% actually. But for flood and drought, the accuracy more than 90%.
Thank you, Professor Baba. So the accuracy is quite high, yeah, for flood and drought, 90%, more than 90% accuracy. Yeah. But for BLB is a kind of disease, yeah, Professor. Yeah.
Yes, yes.
It's for paddy, yeah, still 70%.
Yeah.
So any other question about this? A very interesting presentation, yeah, about how to detect the disease on paddy plantations, yeah, using drone.
May I
Please.
maybe this is not questions because but more comments. This is may I, Dr. Kalisa, just for 1 minute?
Yes, please. Yes, please.
Yeah, because
Dr.
my background is economics, resource economics, or actually, so I don't have idea about more technical things, but I think this is a very important research because we know that farming and maybe also later on fisheries are still like behind and the insurance and the like because of the uncertainty. And I think my questions is how, yeah, I don't know. I think the agriculture insurance or crop insurance have been implemented in I don't know in Indonesia, but in other countries. But my question is, considering the climate pattern, what do you think? How it will what we called affect the scheme of the insurance? I mean, like because of the climate change affect quite a significant. So maybe the risk or the uncertainty is quite high. So in your opinion, how this could be applied in the agriculture sector for the insurance? Would it be more feasible for the insurance sector to engage with in this sector because of the higher uncertainty due to the, let's say, climate factor, something like that?
Okay, thank you, Dr. Eva, for your question. Please, Professor Baba, answer in short because
Yeah.
Yes, Professor.
Basically, our research related to climate change response actually, since the increase or the dynamic of pest and disease, as well as the meteorological effect due to uh, climate change. Of course, uh, so far, the concern related to the shortage of the extension and pest observer actually. So far, the decrease of the staff, I think almost 70%. The number decreased into 70%. So they have a problem, but the problem is still there, and the government need or want to protect the farmers' concern. That's why we developed the alternative method to make assessment. And the previous method, the current method actually is quite subjective, and many we can say hijack there, ethics problem. That's why we introduce more technological approach. And of course, the handicap is not the government willingness, but political actually, because they want also to support the insurance company. That's why so far we have concern there. And another thing is, and I can consider as political again, the damage failure should be above 75%. That's the criteria developed by the current method. And we know the average failure of the crop of padi in Indonesia, not 75%, but about 50%. So we consider actually we need to create new criteria. Of course, the purpose of the project directly or research directly is not to change the criteria, but we want also to influence the government to change the criteria. That's another topic that we already conducted. But another thing, the Ministry of Agriculture also asked what they want is to protect crops before the what we call the pest and disease or drought or flood comes. Actually, that's why we develop a kind of early warning system.
Okay. So it's more on preventive side,
Yes,
Pak Baba,
yes.
Okay, thank you.
Yeah, thank you, Professor Baba and Dr. Eva, for your question. A very interesting discussion, but we have to finish this session because of the time. So please give applause to Professor Baba for his presentation. Yeah, thank you.
Thank you.
Thank you, Professor. So our next speaker will be Professor Xiwen Luo from the South China Agricultural University, and the presentation will be entitled Explore and Practice of Unmanned Farm. Please, Professor Xiwen Luo, the time is yours.
Because Professor Xiwen Luo is attending another conference, so we have a video for his presentation. Now I'd like to show my screen.
Yes, thank you, Professor.
Can you see clearly?
Yes, we can, Professor. Yeah.
Okay, let's start.
Sorry, we cannot hear the sound, Professor. Have you shared the sound as well? When sharing the screen, you should also share sound.
麦克风语系统切换到它电脑的
I cannot hear the sound of the video.
麦克风。
I think when you first share the screen, there's an option on the bottom left to share sound. Yeah. You can unshare first, but then tick the bottom left of the share screen option.
So give us a second. Yeah.
Yes.
用的是那个视网麦克风，你要用视网的那个扬声器。
You can stop share first, Professor. Stop share and then share again, but tick the bottom left button. Yeah. Stop share.
不是这样，它声音还是音频的那个。
You can probably stop share first, Professor Yuan.
Give a second. Stop the share and restart again.
Yeah, you can stop share and then share again. But when you share the screen, you tick the bottom left share sound option.
Ah, yes, I see.
Yeah,
Share the
okay.
sound.
Okay, share sound, and then you start again. Yeah. Yeah, can you share the screen again, Professor?
I think there is a pretty good.
And ticking the share sound. Yeah, please.
Hi, everybody.
Yeah,
I
we
am
can hear
Stephen
you.
Law
Thank you.
from South China Agricultural University, People's Republic of China. The title of my presentation is Explore and the Practice of Unmanned Farm. As we know, smart agriculture is the development direction of modern agriculture, and the unmanned farm is an important way to realize smart agriculture. Today, I will introduce the explore and the practice of unmanned nice farm developed by South China Agricultural University. This is the outline of my presentation. The smart agriculture is the development. The smart agriculture is the development direction of modern agriculture. Can improve labor productivity, land production rate, and resource utilization rate. Formerly, one farmer with a cattle can only till 0.13 hectares paddy land per day, and now a rotary tiller can till 1.3 hectares per hour. One farmer can only transplant 0.067 hectares per day. An unmanned rice transplant can transplant 0.33 hectares per hour. One farmer can only sow 0.4 hectares paddy land or 0.67 hectare dry land per day. An amended rice drying sheet can store 0.33 hectare per hour in paddy land or 1.33 hectare per hour in dry land. One farm can only finish 0.2 hectare of spray per day, and UAV can spray 13 hectares per hour. One farmer can only harvest 0.033 hectare rice per day, and a man harvest can harvest 0.33 to 0.4 hectare rice per hour. By using the better GNSS technology for navigation of unmanned machinery, the lighting area of unmanned machinery is less than 2.5 centimeters, and the land utilization can be improved by 0.5 to 1%. Take land delivery as an example. Land delivery can save water 20 to 30%, save fertilizer 5 to 10%, increase output 5 to 10%, improve efficiency 30% compared with the traditional delivering method. Now, I will introduce the export and the practice of unmanned farm, including the concept of unmanned farm, the key technology for unmanned farm, and the unmanned rice farm developed by South China Agricultural University. Take the planned production as an example. The unmanned farm should have the following 5 functions. First, all the production link, including tillage, planting, management, and housing, should be unmanned. Second, the unmanned machineries can automatically transfer between garage and the field. Third, the machineries can automatically avoid obstacles and stop by emergency transit. Fourth, the whole production process are real-time monitored. Fifth, decision-making and precision operation are intelligence-based and unmanned. There are 4 key technologies for unmanned farm, including digital information perception, intelligent decision-making, precision operation, and intelligent management. Take the planned production as example. Digital information perception includes soil information, such as soil tillage resistance, soil fertilizer, and soil moisture, crop growth information, and crop disease, insect pest, and weed information. The platform for digital information perception includes satellite, aircraft, and ground machinery. For different purposes, we can use different platforms. For example, if we hope to know the rice plant area of Guangdong province, we can use the satellite image. If we wanted to know the rice growing situation in the form, we can choose the aircraft image. If we wanted to know the digits in the noise form, we have to use the ground machine image. This is an example. South China Agricultural University successfully measured South China Agricultural University successfully measured the nice growth situation by UAV and analyzed the nitrogen status and made nitrogen fitness application map. Results show that nitrogen fitness was reduced by 28% and 22.5% respectively in 2019 early and late night season. Intelligent decision making includes land consolidation, tillage, planting, sowing, field management, and harvesting. Precision operation include automatic navigation and precision operation. Here are some automatic navigation machines developed by South China Agricultural University, such as unmanned rotary cultivator, mass slaver navigation rotary cultivator, 3 unmanned nice seat working simultaneously, higher ground cleaner spray, and so on. Precision operation include tillage, planting, field management, harvesting, and drying. There are some kind of levels based on NASA or satellite figure developed by South China Agricultural University. The leveling position of this level is less than 3.3 centimeters. This is an unmanned nice precision seeder. It is so the rice seeds directly on the field. The unmanned nice precision seeder near nice precision nice shear drop drilling and synchronous flooding and leisure. The field management includes the management of pesticide, fitness, and water. This is a large smart wearable spray. Developed by
I'm sorry, Dr. Yuan, the time is up
of
for
Agricultural
Professor
Science.
Yuan Lao.
Yes, but the video still have another 8 minutes. Maybe I can drag to the end.
Yes, please. Yes, please. Thank you. Because this is 18 minutes video, yeah. Okay, probably move to the end, yes.
I will show a video for our unmanned farm, the rice
Yes.
farm, the first unmanned rice farm of the world.
The drying area of Stratton line is less than 2.5 centimeters. The washing efficiency of one rotary tier is more than 1.3 hectares per hour.
Or perhaps can we share the video to the audience? Yeah.
Link is soaring.
Yes.
This is unmanned dry land seeder. The nice seeds are accurately sown in the field, slow ditching, and dry sowing model. The third production link is field management. The UAVs are used for pesticide spraying and variable rate fertilization. And this is unmanned higher cleaner spray. The fourth production link is harvesting. The unmanned harvester and the unmanned grain transport automatically drive out of the garage. The harvester automatically harvests in the field, and the grain transport waits at the site of the field. When the gallery of the house is near full, the grain transport drives to the site of the house soon. Then the house accurately unloads the rice to the grain transporter. Then it unloads the rice in the truck. Many people care about.
Yeah, this is a video to show how the unmanned farm works by the machines. So for a presentation from Professor Xu Wenluo. Thanks.
Yes, thank you very much, Dr. Yuang. Thank you, Professor Xiwen Lau, for making a video. If possible, probably the video can be shared to participants. If you have the link to the video, so the participants who are interested with this topic can see the video again later, because I think the important part is on the last part of the video, yeah, Professor? So yeah, thank you very much. If you have the link to the video, we can share to the chat room so participants can play again later, especially in the last part of the video. Yeah, thank you.
I have to inquire about the sharing of a video from Xu Wenluo because he's not here now, and maybe later I can reply whether it can be shared or I can send you a link.
Okay, yeah, okay. Thank you, thank you, Professor Yuang, for playing the video of Professor Lau. Okay, due to the limited time, I'm sorry we don't have the discussion, question and answer for this session. Let's move on to our next presenter, Dr. Desrial from IPB will present about the development of fast-track transporter for oil palm. Dr. Desrial, please, the time is yours. Still muted, Pak. Sorry. Yeah.
Okay.
Yes.
Good morning. Thank you very much, Dr. Carlisa, our colleague from IPB, and also from South China Agriculture University, and all attendants. I'm very happy to share our research from IPB University about development of agriculture machinery for palm oil plantation. Okay. Actually, as I hope all of us understand that Indonesia is the biggest producer of palm oil or CPO in the world. So about 59% of CPO come from Indonesia. And this is actually the cycle of the palm oil cultivation, starting from land clearing. So in land clearing, we have to open the land for planting the nursery of the oil palm. Then we transplant the nursery. In the planting, we still do like this without any kind of machinery yet. And for crop maintenance, we do spraying and also fertilizer applicator. And then we continue to the harvesting. Harvesting is the most important in oil palm cultivation because almost 70% activity are doing in this harvesting. Then after 20 or 25 years, the oil palm should be replanting again. Actually, I have some video, but the time is very limited, so I will not play the video all. So this is the general situation of oil palm plantation. There is two type of soil that we usually use. The first is the very flat lowland, or sometimes we call it also peatland. It has organic soil, flat, and unfortunately very low bearing capacity. And in another side, we have also dry land, which is mostly mineral soil. It has a good bearing capacity. However, the situation is very hilly or in the undulating or rolling condition. This is the problem about the collection of the fresh fruit bunch, FFB. So one plot of the oil palm block is usually about 1000 meter by 300 meters. So it is quite very big. And then we have to bring out or collect the FFB from infill into the collection temporary collection area. And it should be done by under either manual or by using the machine. And the most difficult thing, if it is in the undulating area, as you can see here, the area is not regular, and we have to again bring out the fresh fruit bunch, which usually about 20 to 30 ton fresh fruit bunch per year per hectare that we have to transport. So FFB collection machinery is very much important for improving the efficiency. So this is, I summarize the problem of harvesting. First, we still have lack of harvesting labor, improper evacuation route, shortage of reliable transporter. And for national case, potential loss of FFB a year can reach into the 21.9 trillion rupiah per year. It is very big money. And this is actually the conventional carrier for fresh food bunch. Usually they use a wheelbarrow like this, but in the severe location, sometimes they use also basket, like we can see, and sometimes they use also bicycle to bring out the fruit from the field to the collection area. So due to that, IPB University tried to develop the machinery for transporting the fresh fruit bunch of this oil palm. This is our first model. We call it this is fast track 0.1. So it is very simple design because we try to make it as simple as possible so that the farmer can utilize and operate the machine easily. Maximum load is 350 kilogram with 6.5 horsepower engine. I hope you can see the video of the machine working. I just take a short video, and this is how the machine is working in the plantation. So if we check the productivity of this machine, so it is about 5 to 8 ton fresh fruit bunch per day, or it is equivalent with 3 to 4 manual wheelbarrow. So it already increased the efficiency of the collection of fresh fruit bunch. Then we continue to design also the bigger one, which is can be used for either low land or also in hilly area. We call it fast track 0.2. So it has feature with bigger bucket and also It has bigger engine, 10 horsepower, and bulldozer-like steering, and also with hydraulic damping, and it also equipped with steel track, which can give the better traction compared with other machine. So this is how the machine is working in the field. So it can work either in the low bearing capacity of soil, and also it can be also used for hilly area as well. So if we see the productivity, as you can see in this picture, the field productivity about 10 to 15 ton fresh fruit bunch per day, or equal to 5 to 7 manual wheelbarrow. So it's again increase the efficiency and productivity of collecting fruit of the oil palm. And this machine has very good demand from the plantation, and we are very proud to share with you that we already also mass product this machine with very good selling also. We do not stop only with the track type. We also continue to design, like you can see here. This is actually rubber wheel type of transporter. It has a better speed compared with the track type, and it is not only for carrying the fresh fruit bunch, but it can be used also for fertilizer applicator and also for other purpose in agriculture sector. Then we continue also to develop the bigger one. Actually, the recent agriculture machinery company, they are selling combination between tractor and scissor lift bucket, as you can see in this picture. However, it is very heavy, and sometimes it is also stuck in the field. That's why we have idea how to make it smaller and compact. Then we design this machine for smaller one and also compact, and it doesn't make also a very big soil compaction inside the field. And this is the machine. So this machine actually was funded by BPDPKS. This is the Agency for Development of Palm Oil Plantation in Indonesia. So this is the special feature of this machine. It has also scissor lift that can directly dump the fruit into Then we also try to develop the smart fertilizer applicator machine, as you can see in this picture. So it is already combined with the platform of, we call it the Precipump for fertilizer dose recommendation, and also with the machine, and it is using the satellite information control.
Can
the
you
last,
make it shorter? Yeah,
recent-
okay, thank you.
This the last slide from me. So we develop also the harvester. This is actually electric type harvester for fresh fruit bunch, as you can see in this picture. And this is a short video how the machine is working. So it can climb until 12 meters, which is full or plant most already. Thank you very much, Dr. Carlisa. I think that's all from my presentation. Hi.
Thank you, Dr. Desrial, for your excellent presentation. Very interesting. Yeah, again, very interesting presentation, but the time is limited. So I will limit only to one question for Pak Dr. Desrial. Any question? One question only, short question.
May I have one question?
Yes, please.
Okay, thanks for that wonderful presentation. I have just one short question. Because this is a very mature product track, could you tell us the price? Yeah, big track.
What is the price, yeah, Doctor? Yeah.
What's the price?
How about the price, Dr. Desriel?
Oh, the price is about 120 million rupiah. Berapa itu?
US dollar?
120 million rupiah. I'm sorry, we have to. About 10,000 US dollar.
Yeah, 8,000 US dollars.
Yeah.
1,000.
8,000 US dollar per machine. Yeah.
$8,000. Okay, thanks.
Yeah. Thank you,
Thank
Dr.
you.
Yuang, for the question. And thank you, Dr. Desriel, for your presentation. Very excellent research that
Thank you
you've done
very
there.
much.
Thank you. So due to the time, let's move on to the next presenter. The next presenter is from South China Agricultural University, Dr. Wenyu Zhang. He will present about the research on intelligent agricultural machinery technology for unmanned farms. Please, Dr. Wenyu Zhang, the time is yours. You have 10 minutes presentation, and then we will have one question answer. Yeah, only one question. Yeah, for each presenter. One question for each presenter because of the time. I'm sorry. In Indonesia, every Friday we have a Friday prayer, so we have to finish on time. Yeah, please, Professor, the time is yours. Can you share your screen?
Very soon.
Yeah.
Can you hear?
Still, yeah, okay. Yeah, I can see already. Can you make it full screen?
Okay.
Not yet full screen, yeah. Okay, we see the presenter view.
Oh. How to?
I think you should share screen, yeah, instead of share the file.
We already.
Oh, okay. Yes.
Probably the host. Can you make Dr. Yu Wang as the co-host?
We try to fix it soon.
Yeah. The host, can you make the Dr. Yu Wang as the co-host so that it will be easier for her to share screen?
All of participants can share their screen, Dr. Karis.
No, I try to share screen, but I cannot see the whole screen. Nggak bisa all screen gitu, harus pilih salah satu window, jadinya agak sulit. Kalau co-host harusnya bisa.
Oh, sebentar.
Saya sudah coba juga. Can I make a co-host as well, please?
So good.
It's okay?
Yeah, okay, I can see it now. Okay, yeah, please, Professor.
I'll try to. Oh, yes. It's okay. Good morning.
We can see. Yeah,
Professor
good
and-
morning.
Good morning. My name is Wenyu Zhang. I work for the South China Agricultural University Engineering College. I'm delighted to join this online conference. My presentation topic is research on the intelligent agricultural machinery navigation technology for the unmanned farm. The report divides into 4 parts as follows. Part 1 is background. Part 2 is status. Part 3 is key technology. Part 4 is application. First, the background introduced. The challenge of the agricultural labor shortage. Take the Chinese example. Chinese about land air account for the 7% of the world, but we have the 21% of population need to work. So the agricultural labor is the most important result in the agricultural production. Classification state of the International Labor Organization, the age in the labor force, the working population age is 45, but the average in the age in China is 55. So the challenge problem is on the 3 level: aging, stabilization, and part-time employment. How to face the challenge? We need to develop the technology. Traditionally, agriculture is facing the challenge, and the new and smart agriculture development in the future of the countryside as well as the future of the country. The technology includes global precision, the global precision technology, such as GPS, it can be able to smarter tractor to get a real-time prices for position, which is one of the foundational technology for the unmanned farm. By the 5G communication technology, we can connect more the tractor to the achieve the collaborate option. And AI technology can play the important role in the control. Everyone's cooperation and planning the decision making. Unmanned farm is the production method of the smarter agriculture. They reduce the labor cost by 60%, improve the efficiency by the 30%, reduce the fuel by 5%, and increase the income by the 40%. And unmanned farm has followed a 5-point. The last Professor Law has introduced this, so I think I don't need to read the line by line. And scale some scale. Then I will introduce the research on the unmanned farm in the world. In England, the Harvard Allison University, they're building the unmanned wheat farms in the first of all. Then they full coverage the cultivation, management, and harvesting of the wheat. Concord University and the John Deere company also to building some smarter tractor which can outwork in the field. In China, such as the South China Agricultural University by the team of the Lo Shiwen, Also to cover all part of the rice land in the first of all, because the Chinese like to eat the rice. I think Indonesia also like it. All other companies, such as Shanghai, Lianshi, or AI Force Technological, joined to building unmanned farms. More than 200 farms started building in the China now. How to say that, like bamboos shot up the spring ring. There were 3 base technology for the unmanned farms: agronomy, machinery, and the information. My work is first in the machinery. So I will introduce the king of the technology is auto navigation technology. Auto navigation technology is the king of the technology for the unmanned farm. We can see the right video. All the pilots make the straight line, and human pilot make the curve line. The curve line will lost some part of field in black. And navigation has followed the three points. Low speed, I think the high max speed is 10 kilometers per hour. And second point is centimeter level. 3 point is complex environment interference. Base characteristics of navigation, like this picture. Have a 3 point: position, control, and action. All the research around these 3 points: how to position, how to control, and how to action. Make an example for the ground work. Take a tracking harvester as an example. The first we planned target play, target pass. Then to draw the position from the GPS and handing from the AHAS, and then to draw and the calculation the error input to the tracking pass navigation controller, and to output the hunting signal.
Dr. Zhang, sorry, your time is up. Can you sum up? Yeah, thank you.
Okay. To make the harvest turning. This picture to show a base of the method is 0% the method for the tracking. We get the distance harvest with the target pass, and handing arrow with the speed and pass. Then to set per wheel the distance L to calculate the turning radial R by the equal on the right. Based the R, we send the turning signal to the harvester for the turning. The video is working in the house. At last, we have the 3 video for the delivery, land, sowing, ministry, and harvest. That's all. Thank you very much.
Yeah, thank you, Dr. Zhang, for your presentation. So we will open for one short question. Please, do you have any question? No? A very interesting presentation, but probably we can save the question for later. Yeah, thank you very much again, Dr. Wenyu Zhang, for your presentation. Okay, no question, only one question? No? Okay, if no question, then we will move on to the next presenter. Next presenter is from Professor Sudrajat from IPB University, and he will present about the PreciPalm Precision Agriculture Platform for oil palm. Please, Professor Sudrajat, the time is yours.
Thank you, Bu Karissa. Good morning, ladies and gentlemen. First of all, I would like to thank to the opportunity to present our research in this seminar. Especially, I would like to thank to steering committee, Pak Professor Iskandar Julkarnain and Ibu Eva Anggraini. My name is Sudrajat from Department of Agronomy and Horticulture, Faculty of Agriculture, IPB University. My topic is PreciPalm, is fertilizer recommendation application system for oil palm plantation. The first question is, why palm oil? Palm oil, as we know, that is our source of food, feed, biofuel, fiber. The second, palm oil is staple food. The third one has a role in domestic economy and also has high commercial value. And in Indonesia, palm oil in terms of agroclimate is very suitable. And also the palm oil has high productivity compared to the other vegetable oil. And finally, of course, as a source of material of food and chemical industry. In this slide, we can see that palm oil production of Indonesia and Malaysia grow rapidly. Both produce more than 80% of palm oil production in the world, as mentioned by Pak Desrial before. The advantage of development of palm oil in Indonesia, first, IPO is...
Can you full screen, Prof. Sudrajat? I'm sorry, can you full screen the slide? Yeah, thank you.
Okay.
Okay, Professor. Thank you.
First, CPO and palm oil kernel price is increased due to increased consumption in China and India. The second, CPO and palm kernel oil are oil that have a wide market in the world. We can find easily in Europe, Africa, America, Asia, and so on. The third one is the productivity is higher than other vegetable oil like soybean, sunflower, rapeseed, and so on. And the fourth one, it is a basic ingredient for various food, cosmetic, pharmaceutical, and biofuel products. We can find easily in the supermarket more one half of the product consists of palm oil. In Indonesia, especially in Sumatra and Kalimantan, the two islands is a very important producer for palm oil. In Sumatra, for example, especially in North Sumatra and Rio and South Sumatra, meanwhile for the Kalimantan is East Kalimantan and South Kalimantan. And also for the growth of oil palm area and CPO production, we can see in this slide that the total area is about 14.60 million hectares, and for the production is about 47 million tons. So we have a amount of the CPO production. And this one is our research, Prof. Kudang, me, and Dr. Hari and Dr. Indra Kalyana from the other department. We collaboration to work together to make what we call PreciPalm. In this slide, we can see that the increasing of the CPO is relatively stable. And for the cost production is increased significantly. So for this reason, we have to find the new technology. In terms of the plantation operation cost, fertilizer is very important. More than 47%, the cost of operational cost come from the fertilizer. And the other part, we have a problem because the productivity potential is 25 ton FFB per hectare per year, and the production actual is only 14 ton per hectare per year. So we have a gap 11 ton FFB per hectare or 44% the gap the productivity, and also the cost to produce the CPO more higher than in Malaysia. As we know that the productivity depend on the plant genetic, environment, technology, and management. So our concern is how to increase the fertilizer. Fertilizer, as I mentioned before, that for the fertilizer is for 50%, and also the dose depend on the plant growth and soil fertility, and also depend on the product quality. Precipalum is a system based on the precision agriculture. Is innovation to increase fertilizer efficiency for oil palm production. And our Precipalum use the data from satellite Sentinel-2, and then the data processed using decision support system fertilizer to determine the nutrient status and fertilizer recommendation. So we have to determine the nutrient status in the leaf of palm oil. As we know that the resolution spatial of the satellite is 10 meter, 20 meter, and 60 meters. And also the Sentinel-2 have 13 bandwidth. So precision agriculture is a business process use technology so that the observation and treatment are determined with precision according to the variability of location, plant, and climate. And also precision agriculture, it should be right location, right time, right quantity, and also right method. Improvement of agriculture system to be more efficient when using resource, more profitable, and also more sustainable. Based on the research of the Kellogg, the advantage of the precision agriculture, if we reduce 30% of fertilizer, the productivity can increase 15%. So for this reason, we have to increase the fertilizer efficiency. Why Sentinel-2E? Because Sentinel data has band that can detect plant, and Sentinel data has a resolution of 10 meters. Sentinel data has a 7-day temporary resolution, It means that we can monitor the plant nutrition status monthly, quarterly, or semi-annually. And also Sentinel data is open for the public. There is no fee to acquire and to utilize the Sentinel-2. What the advantage of the using Prazipalam? The first, of course, data acquisition and data analysis are very, very fast. Our experience that to determine the recommendation, we need only 2 seconds each hectare. And also using this method have the accurate the recommendation. And also easily our system is easy to visualize of the nutritional status and the result. And the important is it is a very interesting in terms of efficiency in cost, time, and labor. As we know that if we use the method, conventional method, we have to analyze one sample need more than 2 or 3 months. So it is very important to using our software.
Sorry, Prof, the time is up. Can you make it shorter? Thank you.
Okay. 1 minute, Bu Karlisa. So principal analysis process, yeah, we have a block, we have an image, and also we have the age of the plant, we have the historical fertilizer history, and our system using the machine learning can determine the nutrient status and also can determine the recommendation. This is an example for using Prazipalam. This is the nitrogen status. The total area is about 180 hectare. So we can see in the yellow color, it means deficiency. If the green color, it means sufficient for nitrogen. Same with the phosphor and also for the potassium. This is the principal model accuracy. The first model version 2021, the nitrogen with the accuracy is 93%, and the new version 2022 is increased, become 95%. We have still work more to increase the accuracy for magnesium and for the potassium. This is the example for the recommendation. We can determine the dose for plant for each hectare, and also easily to calculate the need of the total fertilizer. Thank you, Bu Karlisa.
Yeah, thank you, Professor Sudrajat, for your presentation. I think we don't really have time for the question and answer, so can we keep it until the last part of this whole session? Yeah, Prof. Sudrajat, yeah. We will keep the question and answer for the last part of this session if we still have time. Okay, applause for Professor Sudrajat. Thank you very much for your excellent presentation. Now we will move on to the next presenter. The next presenter is Dr. Jia-Huan Lu from South China Agricultural University. Dr. Jia-Huan Lu will present about battery management technologies for new energy vehicles. Please, doctor, the time is yours.
Hello. Hello.
Yes, hello, doctor.
See me?
Yeah, you can share your screen, and the time is 10 minutes, doctor. Thank you.
分开，我们再分开，要不然会非常错。先看 PPT，不是先播放再改，要不然他就搞视频了。
While waiting for Dr. Lu sharing the screen, do you have one question probably for Professor Sudrajat? Anyone have question for Prof. Derajat about Prestipalm? No, okay. So if no question, let's move on to Dr. Lu's presentation. Yes, please, doctor.
No? Good? It's okay?
Can you see the screen?
Not yet. It's still loading. Yeah, we can see it now. Yeah, please make it full screen.
It's full already. It's on display.
We can see the presenter view. Yeah, not the full screen.
Yeah, I know.
We will restart again.
Okay, let's start again. Is it okay?
We cannot see the full screen, but we see the presenter view. Okay, now it's okay. Yeah. Thank you. Please start, doctor. It's missing again, the screen.
Yeah. Wait, do that again. Can you see my screen? Can you see my slide? Hello? Hello?
Yeah. Okay. Hello. Yes, please.
Oh, okay. Okay, let's go.
Yeah. Okay. Please start. Thank you.
Everyone, thanks. My name is Jiahuan Lu. Firstly, I would like to thank IPB University in Indonesia and South China Agricultural University for providing me with this opportunity to share my research. Today, I will share you my long-term research on battery management technology for new energy vehicles. Sorry to say that my presentation may be strange to many of you, as it is mainly focused on automotive industrial, but I think it is also interesting for everyone. So let's go. So, allow me to introduce myself. I am a graduate of Beijing Institute of Technology and currently hold the position of associate professor and master's supervisor at SCAU. Our university is located in the Beijing flower city, the beautiful flower city of Guangzhou, China, at the core of the Guangdong, Hong Kong, Macau Greater Bay Area. Our team is led by Professor Steven Law, and in recent years, we have established the world's first unmanned wind farm in China and are dedicated to promoting mechanization, intelligent and low carbonization in agricultural production. So we warmly welcome your visit and guidance. Currently, carbon emissions have led to global warming and environmental degradation. So we can see the polar bear are becoming homeless. And then let's take a look at the distribution of global carbon emission in the transportation sector in 2022. As you can see, emissions from cars and vans account for nearly 15%, and emission from all vehicles exceeds 18%. That's right, the main culprit behind all this is the internal combustion engine. So, to save our planet, new energy vehicles have become the primary development direction for global transportation, as they not only reduce carbon emissions, but also offer numerous
advantages. For example, internal combustion engine vehicles relied on non-renewable energy sources and making them unsustainable. And in comparison, new energy vehicles can harness sustainable energy resources such as solar and wind power. Internal combustion engine vehicles produce strong vibrations and noise, while new energy vehicles, thanks to the batteries, are smooth and quiet. So internal combustion engine vehicles require a drive shaft to transmit power to the wheels, whereas new energy vehicles can utilize in-wheel motors allowing power to be transmitted to the wheels through wires alone. With the increasing simplification of the structural design of new energy vehicles, we are also facing new challenges. That is battery management. The advantages of electrical design have made the mechanical design of electric vehicles easier, but the issue of battery management has become more prominent. Let's take a look together at why battery management is necessary. Batteries are essentially a fully enclosed mechanical system. As such, we can treat them as a black box, where only information we can attain through sensors is current, voltage, and temperature, while very few other parameters can be monitored. Consequently, the information required for battery decision making is very limited, leaving many questions unanswered, such as how long can it continue to be used? Where is limit life? How much remaining lifespan is there? So battery management is like a doctor stethoscope, evaluating the state of a battery based on its external performance, such as current and voltage, and providing a basis for battery decision making. Next, I will introduce 3 states of battery management that we focus on: state of charge (SOC), state of power (SOP), and state of health (SOH). So what is battery SOC? Battery SOC is used to answer the question of how much longer the battery can continue to be used. Generally, after a battery is fully charged, SOC can be calculated to use this equation. However, in most cases, the battery is not fully charged, so this term is not 1, but an unknown variable. What should we do? We have found that there is a one-to-one correspondence between the open circuit voltage and the SOC. Therefore, we only need to use the voltage at the moment of cold start to look up the table and calculate the SOC. Second, what is battery SOP? SOP is used to answer the question of where the limit of the battery lies. When battery is under high load and needs to output high power, SOP refers to a power limit at that height. How do we estimate it? We can treat the battery as a model composed of components such as voltage sources, resistors, and capacitors, and then solve the model parameters based on the observed current and voltage. Once we have the parameter, we can perform Taylor extension of the parameters on the SOC, extrapolate the limit of parameters, and finally substitute the parameters back into the model to calculate SOP. The third, what is battery state of health? As we all know, batteries inevitably age and cause capacity loss. SOH is used to describe the degree of capacity loss in battery. We can use convolutional neural networks to mine agent features from current and voltage and calculate SOH. Additionally, we can utilize recurrent neural networks to extrapolate the future agent trajectory of the battery, thereby calculating how much remaining lifespan remains. After knowing SOC, SOP, and SOH, the battery becomes a digitalized box instead of a black box, making it easy to design charging and discharging strategies for it. Let's draw some conclusion. The tenth of the new agent revolution is irreversible. The battery management is the key of this. The new energy revolution has been in full swing in the automobile industry, but it has just begun in the agricultural industry. So future development of new energy in agriculture requires joint efforts. So that's all. Thank you all for listening and participating. I hope my presentation has been informative and helpful. If you have any questions and suggestions, please feel free to contact me. And the last, welcome to visit our beautiful capsules and taste our self-developed yogurt. It is an advertisement. Thank you.
Yes, thank you very much, Dr. Lu, for your excellent presentation. Very interesting. Yeah, thank you very much. So I would like to open for one question for Dr. Lu. Do you have any question? I think this is a nice presentation and probably can be collaborated with Pak Desriel, yeah, probably, yeah. About the fast track and the battery management technology, yeah, probably. Okay, one question from the chat box, yeah. Do you want to ask directly, can we apply battery for plowing? Can you help answer, Dr. Lu? Question from the chat box. From Mr. Tritunggal, can we apply battery for plowing?
Sure, battery is a general power source for any machinery. So
okay, and how to combine this for horticulture on breeding technique?
Horticultural breeding,
as mentioned probably by Dr. Lu, yeah, the battery can be used in a general application, yeah, Dr. Lu, yeah, so it can be applied to any applications, yeah, Dr. Lu, yeah.
Yeah, it is a general, it is a power source for any machinery. So
yeah. Okay, thank you, Dr. Lu. So applause for Dr. Lu. Thank you very much. I think it's very many applications can be integrated. I think can be collaborated with your research because it's very general, and we have many also vehicles, yeah, for automation in agriculture. So I think it's a very nice opportunity for joining the research. Thank you, Dr. Lu, again. Okay, thank you. Now let's move on to the next presentation by Dr. Yeni Herdieni from IPB University. She will present about the machine vision for agriculture and forestry. Please, Dr. Yeni, the time is yours.
Okay, thank you very much, Bu Carlisa. I will show the screen. Wait a minute. Screen. Oh, okay. Can you see the screen, Bu Carlisa?
Yeah, Bu, you can see.
Okay,
Yes,
thank
Bu, but not yet full screen, Bu.
Wait a minute. Full screen. Okay.
Yeah, it's fine, Bu. Yeah, thank you, Bu.
Okay. Yeah. Okay. Good morning, everyone. My name is Yeni Herdiani. I'm from Department of Computer Science of IPB. So I'm working in computer vision for Life Sciences Research Group. So thank you very much for having me in a short lecture today. So my presentation, I will present my talk about machine vision for agriculture and forestry. So here is my topics. So there are 4 topics that we'll talk about. The first one is about what is a mission vision. The second one about mission vision for agriculture, and then mission vision for forestry. And the last one is challenges and opportunities. So I would like to share to all of you an overview of our research works in the last 3 years. So what is a mission vision? So I will give you an overview about this one. So a mission vision is the substitution of the human visual sense and adjustment capabilities with the video camera and computer to perform an inspection task. So here we can see from the pictures that there are 3 components element that we have to provide to make a computer vision. The first one is image acquisition. The second one is about the analysis, and the last one is the integration and the applications, integration of the application. So the first works is I would like to share with you is about our research work collaboration with Ministry of Agriculture. So we are working on machine vision for stomatal density analysis for plant breeding. So this collaboration started from last year. And then in this work, we are observe the patchouli plants. So the patchouli plants is the herbs which possess many entropic properties and widely used in fragrance industry. So this research will be used also for plant breeding in the Ministry of Agriculture. So in patchouli oils, in patchouli leaves, especially stomatal behavior can be used or a good indicator for health and also indicator for the oil production. So that's why we observe the stomatal behavior by using microscopic images. So you on the screen, you can see the examples of the microscope images that we are used to analyze stomatal behavior in plants. Yeah, so here are the data acquisition that we use for this research. So we use prepared whole mount to get the pictures, and then we use the microscope to obtain the microscopic images. And then we get the different quality of microscopic images. And then from here, we collect some images. And then after that, we make machine learning to find or to detect the stomata on the microscopic images. So from here, we are working on modeling how to detect the density of the stomata to identify the oil production. The second one, this is our research collaboration with the Plant Protection Department of IPB. So in this research work, we develop machine visions for automatic diagnosis of begomovirus in horticulture of crops. So as we know that the begomovirus disease is an emerging threat to vegetable production. In many crops, we can find easily this disease. So in this work, we observed the 3 crops, chili, long bean, and also eggplants. And then we collected data from many plantation and also from the field by using the camera smartphone and also camera pocket. And then from here, we have challenges to detect the virus or this disease. On the other hand, we also found that we have the similar symptom of the nutrient deficiency. And then, if you can see from the screens, begomovirus disease and nutrient deficiency almost has similar symptoms. So this is our challenge to construct the good model to differentiate these symptoms. And then this is the examples of our models. So the fully automated begomovirus detection using deep learning. So for this work, we had a good performance, but in the first step, we only differentiate two classes. The first one is for the positive begomovirus, and the other hand is negative begomovirus. And the further works, we are continued works to also to identify the other symptom like nutrient deficiency or another disease. And the third one, this is the research collaboration with PT Arara Abadi, is one of the Sinar Mas Forestry company. And then this works is about machine vision for disease monitoring in nursery. As we know that PT Arara Abadi provide the material raw for the papers by using acacia. From here, we work on nurseries, and then we work on the acacia plants. So the problem in acacia nursery area is the presence of the disease caused by the Xanthomonas species. So Xanthomonas is a bacterial leaf blight that causes significant losses in procurement of the acacia seedling. So this is the area of our research, and this is the symptoms of the Xanthomonas leaf blight. In this research, we also provide the IoT. We install the IoT in the nursery. We have a camera, and then we put camera on the boom sprayer in the nursery. And also we provide the PC and UPS to connect with our computers. And then this is the examples of the model that we built by using machine learning. And the last one, this is the fourth research works that we have now is research collaboration within IPB and also Indonesian Research Rubber Research Institute. So we start from 2 years ago, and then this is the last year. So we work on machine vision for disease monitoring in rubber plantations. So for the motivation of these works is, as we know that this disease in rubber plantation, we found the new disease that we call it pestaloptiosis or rubber leaf fall disease. So this disease in Indonesia currently has been spread to provinces of Lampung, Central Java, East Java, South Kalimantan, and also Central Sulawesi. And in last year, the total area of disease is more than 22,000 hectares, and causing loss the plant canopy more than 15 years, and latex production, loss of the latex production more than 25%. We also found the challenges on this research work, that we found the weeds on the ground because of the disease. The canopy open because the leaf fall, and then this is also a significant contributors to the decline in the crop yield and also the quality. So we worked on to these problems. So in this research work, we have many.
The time is up, Dr. Yeni. The time is up. Please make it shorter. Thank you.
So in this work, we found we use many equipment, so drone cameras and satellite, and also local weather stations. And for the weed segmentation, we use also a modified deep learning. And then, as you can see from the screens, the results of the results of the segmentations and the accuracy rate of this model is 95%. And this one is also, we observe the disease severity of disease by using a random forest. And the last one, we also make a model prediction by using time series model. So in this work, we observe the phenology of the rubber, and then we found that there is correlation between temperature, precipitation, and also NDVI. So we found some challenges from this work. So first one is variable environmental condition, crop and plant variability, data annotation and collection, real-time processing, integration with other technology, and affordability and accessibility. So addressing these challenges and also leveraging the opportunities in agriculture by using machine vision or computer vision research can lead to more sustainable and efficient, productive and farming practices. So thank you very much for the time. So I hope from this short lecture, we have a good discussion and also collaboration with South China Agriculture University. Thank you very much, Bu Karlisa.
Yeah, thank you, Bu Yeni, for your excellent presentation. I would like to open for one question, short question. Any question? So this is about the software, yeah, about the machine vision, yeah. From the previous presenters, we see that most of the presenters are on the engineering side, and this is more on the software side, yeah. So I think this is a very nice opportunity to make collaborations, yeah, from the engineering side and the software side. Any question? No. Okay, no. If no question, then thank you, Dr. Yeni, for your presentation. Oh, any question? Ada yang open ya, Prof. Sudrajat?
In the chat, Bu Karlisa.
Oh, in the chat. Okay, one question in the chat. Yeah. Please, Bu Yeni.
How long you can
How
long you can be detected a virus on this plant could be protected for maturity age, and is a possible protect for plant? Oh, you mean that for the applications or for the research? So actually, if your question is about the period of the research, so our work starts from last year. So we have been collected data for 1 year and have data more than 10,000 images. But for the application, we still on progress. So I hope in the beginning of next year, we will finish the application so we can test the application in the field.
Yeah, thank you, Dr. Yeni, for your answer. Now I will like to move on to the next presenter. Thank you again, Dr. Yeni. Hopefully we can have a good collaboration. Yeah, next presenter will be from South China Agricultural University, Dr. Juan Loy. Yeah, are you ready? Yeah, please share your screen and the time is yours. Thank you.
This is screen.
Can you see my screen, please?
Yes, we can see your screen already. Please, Dr. Juan Liao.
Okay. Should I begin?
Yes, we can see your screen already, but your voice is quite slow, yeah.
Slow. Oh, sorry.
Low. The sound is too low, probably.
Okay. Can you hear me, please? Can you
Yes,
hear
yes,
me?
we can hear you. Yes, okay. Yes, please.
Good morning, ladies and gentlemen. Thank you very much for giving me this opportunity to do this presentation. The topic of my presentation is research on crop pest insects and disease identification and classification. I'm sorry.
Okay, it's okay.
It's the outline of my presentation. As we know, there are three major digital information perception technologies, including satellite, aircraft, and ground machinery. The satellite remote sensing is for global scale technology information perception due to its ability for large scale measuring, but it has the disadvantages of time and weather limitation problems. And the area remote sensing is for regional scale information perception. It is low cost, high flexibility, and timeless and high precision compared with the satellite. The ground machinery is for sample plot scale measuring. It is easy operating, but the efficiency is low. One of the most important part of workers we have done is the rice BPH identification and hazard level classification. As we know, rice is one of the 3 major food crops in the world. More than half of the world's population depends on rice as a staple food. Pests and diseases have always been one of the major crop disasters for rice. In 2019, loss of rice production worldwide has reached 30% due to pest insects and diseases. Rice plant hopper is one of the main pest insects distributing all over the world, especially in Asia and in China. The most harmful plant hopper to rice is brown plant hopper, which we also call BPH for abbreviation. The detection of BPH by using intelligent technologies is significantly important for BPH controlling, but it is very difficult to detect the rice BPH because most of them are distributing on the stem of the rice. Hyperspectral technology is widely used in crop pest insect detection due to its excellent ability on pest insects detection their in their early stage by analyzing the spectrum feature of crops. Based on these backgrounds, we perceived the spectral information of rice stem and canopy damage by BPH using hyperspectral technology for BPH identification and hazard level classification. The 2 main devices we used were ASD field spec and nano HPV. The BPH levels were set to 4 levels based on the density of BPH on 100 rice plants. 20 spectral feature plants were selected for rice canopy and rice stem respectively, and 3 datasets were used for the BPH identification, including the dataset of stone spectral feature, which obtained the accuracy of 84.8%, and the other dataset is canopy spectral feature bands, which obtained the accuracy of 81.5%, and the information fusing of stem and canopy spectral feature bands module was also used for BPH identification, which obtained the accuracy of 92.1%. The confusion matrix was employed for the agreement between predicted level classification of BPH and the 2 level classification of BPH hazard. It can be seen in this table. The confusing information performed much better than than the rice stone spectra and rice canopy spectra in BPH hazard level classification. Conclusions. The method proposed in this work is to identify the BPH damage on rice plants and to classify the BPH hazard level. The specific research conclusions are as follows. The spectrum feature of rice stem and canopy were perceived and used for rice BPH identification and classification. The spectrum feature bands were selected for rice stem and canopy, and the BFS modules based on datasets of rice stem, canopy, and future information of rice stem and canopy were built and used for BPH identification and hazard level classification. The predicted module of rice stem and canopy confusing information performed much better both than stem and canopy spectrum in BPH identification and hazard level classification. Another work we have done was the cotton verticillium wilt information perception. As we know, cotton is one of the most important industry crops in the world. About 25% of the cotton all over the world is planted in China. Verticillium wilt is one of the most serious diseases harming cotton. It is widely distributed all over the world. The hazard of verticillium wilt was set to 4 levels according to the proportion of the verticillium wilt disease spot on cotton leaf. YOLO 7 SEG was employed as the identification module for cotton verticillium wilt. These are the segmentation results by YOLO 7 module. And this is the cotton verticillium wilt hazard level classification results by YOLO 7 SEG module. The cotton leaf in picture A to picture D were the cotton leaf in picture A to picture B were classified to level 1 to level 4 respectively by the module of YOLO SEG module.
Sorry, doctor, your time is up. Yeah, your time is up, doctor. Please make it shorter. Thank you.
Okay, the last slide, please. Conclusions and the future works. Methods proposed in this work was to identify the verticillium wilt damage on cotton leaves and to classify the verticillium wilt hazard levels. Following works have been done. More than 1,000 pictures of cotton leaves with verticillium wilt disease spots were obtained by visual light camera. Cotton verticillium wilt was identified and hazard levels were classified by employing YOLO 7 SEG module. The accuracy levels classification was 86%. Based on these above works, the following works should be carried out in the future. First is to lightweight the cotton verticillium wilt identification and classification module. Second, to design the cotton verticillium wilt real-time detection software. That's all of my presentation. Thank you.
Thank you, Dr. Liao, for your presentation. There is one question in the chat box. If you, we still have time for one question. Yeah. So the question is, how will you manage the pests or diseases after you detect them chemically? Yeah.
Oh, sorry.
How will you manage the pest after detecting the pest?
Yes, it's the basic works we have done, and after that we will control the disease and the pests, insect pests in the future.
Okay, thank you. And another in the chat box, how can we create BPH and natural enemies model after paddy treated with insecticides? Hello, doctor?
Yes, we can control the BPH, like the BPH or the cotton verticillium wilt by the mite, maybe by the mite, and we can operate the insecticides according to the mite.
Okay, yeah, thank you, doctor, for your answer and excellent presentation. I guess your research team is quite related to what Professor Baba already presented, yeah, in the beginning of this session, and also what Ibu Yeni also, yeah, Ibu Dr. Yeni already presented about detection of insects and disease using machine vision. Yeah, and Professor Baba also conduct research, yeah, about the early damage assessment of rice fields. Yeah. So I think it's very much related also to your work. So I hope we can have a good collaboration on that field. Yeah, thank you very much, Dr. Liao. Okay, now let's move on to the next presentation. The next will be from Professor Awang Maharijaya from IPB University about smart horticulture. Yeah, Professor Awang, the time is yours.
Thank you, Bu Carlisa. Good morning. Nice to meet you all. Thanks for the time. Today, I'm going to talk about a short introductory talk about smart horticulture, especially in the tropics. First, why in the tropic? Because Indonesia, well known as a tropical region, and I think some part of the China also part of the tropical region. And this tropical region is very important because I think more than 60 population of the world are living in this area. And for the agriculture development itself, it's very challenging because there are many more major challenges such as low crop yield caused by a huge number of pests and disease, and then also harsh climate, and then soil erosion, deforestation, and climate change as well. Therefore, I'm really happy to be here to listen many interesting topic delivered before. Okay, so I'm going to talk about the horticulture. Horticulture, including the fruit, vegetable, and then biopharmaca, and also ornamental horticulture. And there are many, there are many ways to use the horticulture for better earning because it's give for more income compared to the staple food, for instance, and then it will give more jobs because in horticulture commodity usually it is more intensive labors, and then also for better living, yeah, for food security, it can provide nutrition and health, and also therapy, and also for the surrounding areas such as for environments and also for city environment. So the challenge is here for horticulture. The horticulture characteristic is mostly defined by its freshness because it's still alive, yeah, and high potential for biological contamination. So it should be controlled very well, yeah. If you compare to paddy, for instance, in paddy maybe you can harvest it and then you can store it easily. But for horticulture, when you harvest it in different time, it will determine the quality of the product because yeah, you can harvest the horticulture product in the early or middle or even the mature stage of the product. So many challenges here, yeah, and it should be fancy. Little cosmetic damage of the product will decrease the quality. You cannot sell it anymore into modern market, for instance. And sometimes, or not sometimes, yeah, mostly it's voluminous and perishable. So it need a lot of handling. So for take care of the horticulture product, more factor, more skills, yeah, more technology are needed. And the characteristic of horticulture product itself is cover a range of diversity of structure, morphology, composition, physiology. Even the same commodity, it can has a difference, very diverse range of uniqueness, yeah, for criteria. So maybe, you know, very specific technology should be addressed in a certain commodity. So it's very challenging, yeah. And upon the harvest, it's constantly changing. Respiration, transpiration, and sensitive to attack by insect and pathogen, and many complex traits are also interact in this situation. And the quality criteria of horticulture products mostly first defined by the visual size, shape, yeah, color, general appearance. But not only that, the quality criteria also defined by its texture and taste. So if we harvest wrong way, yeah, or too late or something, then the quality of for its texture and taste will be different, and also flavor, yeah, aroma, taste, sweetness, acidity, many more. So the tropical horticulture, I will talk about how in the past, the present, and the future, and the challenge, why we need the smart horticulture afterward. So in the past of the horticulture, usually because it's not really aims to fulfill the need of staple food. So it's sometimes considered as a miscellaneous crops. Yeah, it's very limited statistical data, very limited government role, and it's produced in subsistence manner, low quality, low productivity, yeah, low handling technique, etc. But now in our situation, the tropical horticulture is rising. Yeah, there is a shifting from a subsistence manner to business oriented. The use of the quality seed, production technology application, post harvest handling, etc. Yeah. So now it is proven that the horticulture sector is the sectors that can really absorb innovation and technology. Why? Because like what I said before, there are many steps in producing horticulture commodities that are very should be precise and should be well maintained, yeah, to get the quality that we aim. So the present horticulture now already yeah, start to do it in a big scale and industrial way, something like this, yeah. And the young generation in our situation now, they also put more attention to it, and they tend to use technology. They tend to use different variety that can meet the market, yeah. And then the seedling technology, seedling industry also already there, and it's open opportunity for us even, yeah, for processing the horticulture product afterwards to be delivered easily to the consumer. So the challenge in the future of tropical horticulture consists of population increase, yeah, food consumption per capita increase due to the richer world, and then demographic change, and then most important thing is also climate change, less support from natural resources such as less quantity and availability of water, yeah, competing demand for fertilizer, labors, and energy, and also aging farmer. So for the future, we should secure the existing production area through sustainable intensification and expand production capacity of quality produce through intensive extensification. So basically, for producing more, we should keep in mind that we should increase the total agricultural output, but we should limit the total farm input. And the other thing is also we should produce clean product, increase yield, use water more efficient, precising use of fertilizer, the use of machinery to decrease the labor, because the labor price now is also very increased dramatically. And all in all, we should secure the yield based on resistance to pests and disease. Therefore, the monitoring, and also the control using many technology are also important, and tolerance to abiotic stresses, clean technology, and also maybe we can expand the yield using marginal land adaptation and new technological approach. So we already start from present to future. First, we anticipating climate change and agricultural resource scarcity. We can do the control production system, and then we can also invest in tropical adaptation for temperate crops, and then new crops generation, and mitigating climate change by shift vegetables to lower land and fruit trees to higher land, and also using carbon and pollutant absorber crops. For the energy, you see many farmers now, they shift from the left one that use low efficient land to the right one that use a more efficient land with technology for energy for horticulture. And even they tend to use irrigation system wherever the place for production. They aware of the technology of fertigation and irrigation, so we can expand the technology over there. And also control production system, of course, and then breeding for tropical adapted crops. Some crops previously only can be produced in highland, but now in the lowland we can also produce a certain vegetable. So we can use the upland, the highland, for conservation horticulture using a machinery.
Sorry, Professor, your time is up.
Okay, I can just quit here. Don't worry. We can continue with the discussion. I think it is just a introductory talk, and the conclusion is we need smart precision agriculture, because we know that the challenge in our situation is very high. Therefore, from location selection to the logistic and distribution, we have a technology for doing that. From sensors, the new generation breeding, and etc. And this is another example. And I think that's all. And no, sorry, half minute. All in all, we still lack of human resource that mastering this technology. Therefore, we opened the Smart Agriculture study program in IPB University. So I invite a student from China who maybe interested to study about tropical horticulture using smart technology, and collaboration with all of you for research. Thank you, Bu Karlisa. Assalamualaikum warahmatullahi wabarakatuh. Good morning.
Thank you very much, Professor Awang, for a very interesting presentation. Now I would like to open the discussion for one question. Anyone from the audience wants to ask question before the chat?
Yeah.
Yes, please.
Thanks, Professor Awang. Thanks for your interesting presentation. Because we are doing a lot of machinery equipment for the farm. I think some of the machinery can be also applied in horticulture. What kind of equipment can be applied in the early stage, in your opinion?
So for instance, for soil tilling. It is a very common that we can start with it. But in horticulture, we have many unique technique for each
Yeah.
plant to
Different
create the quality of specific commodity. So
about the harvester.
harvester, that's okay, but it should depend on the kind of crops that we want to develop. Thank you.
Yeah, because we have a lot of expert here to study on the invite the harvester for different fruits and vegetables.
Yeah.
Maybe it can be used.
Thank you. And also for forecasting the yield, like high throughput phenotyping method, scanning and see
yes.
how
The digital
how
and
high the yield, etc. Yeah.
Thank you, Professor Awang and Professor Yu for the discussion. I hope we can get collaborations about this horticulture automation and also the machineries itself. Yeah. Thank you, Professor Awang again and Dr. Yu Wang.
Yeah. Thank
Okay,
you.
next presentation is from
the
yes, from the chat box. Yes, please, Professor.
by writing, so you can continue. Alice.
Okay. Thank you, Professor Awang. Yeah, thank you. Next presenter will be from Professor Yu Wang. She will present about the influence of vibration conditions on the suction performance of precision seeders. I think this is very much related also to the smart horticulture presentation that have been presented by Professor Awang. Yeah. So please, Professor Yu Wang, the time is yours.
Thanks, Kalisa. Now I'll try to share my screen. Oh, give me a second. Sorry.
Yes, please.
I can't find the button to. And here. Can you?
Yes, previously we can see, but now it's missing again.
See again. I will
share again. Yeah.
For moments, yeah. You will want to put in the set. The table is nice. That's right.
It's all good. And
yes, it's good. Yeah, I can see it clearly. Yeah, please, Professor.
Okay. Good news, everyone. It's my honor to provide a presentation about my recent research work. The topic is the influence of vibration conditions on suction performance of precision metering device for small seeds. My name is Yu Wang from South China Agricultural University. Now let's start. Okay, my presentation will be divided into 4 parts. First part is about the background. The precision seeding technology is a kind of mechanized seeding process, and it requires a seeding machine place seeds quantitatively in rows and holes according to the crop's agronomic planting requirements.
So it's a crucial approach to enhance the accuracy and the efficiency of the crop planting. It's known that the core components and the key facts affects the accuracy and efficiency of this process technology is metering device, which will enable the precision seeding. And in our group, we have developed one kind of precision seeder. The type is 2BQS10. This seeder takes the X-suction type of metering device. It basically applied for small seeds, which the diameter is within 3 millimeters. The air suction meter device, which is make use of the negative pressure airflow to control the trajectory of the seed movement. It has been considered as the main direction of precision seeding machine development because it has the advantage of the low seed size requirement and the low seed damage rate. Is also able to control the quantitative seeding as one seed, one hole. So this is a major developing direction for the metering device. The working process of this kind of air suction metering device can be divided into 3 main stages. They are seeding filling and seeding carrying and finally releasing in a hole on ground. And also we found that when the seeding machine is working on the field, the force vibration caused by the undulating terrain would affect the uniformity and stability of the seeding. So we have conducted some pre-study investigation of how the force vibration caused. We try to increase the speed of the seeder. When the operation speed up greater than 5 km/h, it will lead to high intensity of vibrations, and we found the seed will detach from the suction hose, cause the mis-seeding. And so at present, most of the precision seeder, the working efficiency is limited and normally less than 5 km/h. But for large size seeds like corn and other crop, the speed can up to more than 10 km/h. So another aspect to affect the seeding precision is, well, once we try to increase the negative pressure to try to adhere the seeds on the hole, but the excessive suction force will cause the resuction, so which will lead to the multiplied seeding. This is not allowed in the precision seeding process. Also, we try to test the exciting on the ground. We found, like shown in the figure, the wide frequency is random, and there's a randomly distribution of the vibration response. And also the response is measured from the vertical direction and increasing with the speed. So try to speed up the precision seeder. We will try to know how the vibration condition affect on the suction performance, and then we will try to figure out how to control the working condition of the metering device. So that's our work, because there is no any quantitative way to study this effects from the vibration on the metering seeder. What we do is based on a numerical simulation model. This model is a bi-directional gas solid coupling model. because we need to combine the skills of the CFD, computational fluid dynamics, and the DEM is a discrete element method. We should investigate the motion of the seed particles and also the flow characteristics in the chamber, and also the interaction between the seed particles and the airflow field. So to build this coupling model, we make use of two software by combining the ANSYS Fluent and the Rocky. So we have built the numerical simulation model for the metering device. For the coupling model, we have used a semi-analytical method because the seeds, the geometrical of the seed is sphere particles, and its diameter is within 3 millimeters. However, for the suction hole, we need to analysis is stress and the airflow around the hole, so the element size is much smaller. So when treating the seed particle size much larger than the size of elements on suction holes, more than 10 times. So we have to use a semi-analytical method in the numerical model. And this is measured on the geometric of meter device. For the negative pressure chamber and the seed box, we use a structured mesh by the hexahedral elements. And for the suction hole, the combined structured and unstructured meshes have been used as many hexahedral and tetrahedral elements. Also, when the metering device operates, the chamber is rotational. So the rotation of chamber have to be treated as a sliding motion, mesh motion. So the suction holes is treated as a moving mesh area, whereas the seeding box and the negative pressure chamber treated as a static mesh areas. This is about the setting of parameters in the model. We set the angle of response of seeds and also the sliding friction angle between the seeds and the steel planes and the seeds and the resin. Also the working condition, we focus on the operation speed from the 0.6 to 8 kilometers per hour, because we try to exceed the temporary speed limit. Now it's 5 kilometers per hour. We try to speed up it, so we want to know what will happen when the speed is more than 5 kilometers per hour. And correspondingly, the rotational speed of the seeding discus is from the 4 RPM to 50 RPM. And the vibration frequency, based on our previous investigation, the low frequency is a major reason to cause the instability of the seeding. So we focus on the 4 to 10 Hertz. Also, the corresponding negative pressure is based on our experimental experiment. Is from the negative 800 to 3000 Pascal. And finally, we can show some streamline.
Sorry, Dr. Yuang, your time is up. Sorry.
Okay, I have lots of things to show yet. This is, I will go through it quickly. And we have to do some verification of our model. And with the model, we can now do lots of exercise and get lots of useful result. We try to analyze this most significant effects on the seeding performance. So we found that the frequency and the amplified vibration is the most significant issue. So we use analysis method to figure out on the different vibration condition what kinds of negative pressure value should be setting to maintain the precision seeding. So now your conclusion. On this work, we majorly provide a feasible quantitatively analysis approach. This approach is a CFD-DEM coupling approach by a numerical model. And also we make use of this model to quantification, to quantitatively study all the factors affecting the quantification rate of carrying seeds. The optimal range of negative pressure value has been figured out for the metering device we developed. Yeah, that's it. Thank you.
Okay, thank you, Dr. Yuang, for your presentation. I don't think we have time for question and answer yet, but do you have probably one question? Okay, now we can probably save the question, for the last session. Thank you, Dr. Yuang. So I would like to invite the next presenter. Our last presenter will be Dr. Deba Supriyanto, and he will present about digital farming development at Agribusiness Technology Park, IPB University. We will have question and answer together for Dr. Yuang and Dr. Supriyanto at the end. Okay, please, Dr. Supriyanto.
Okay, thank you very much, Dr. Carlisa, and also the committee of this activity. Today, I would like to share about the digital farming development of Agribusiness and Technology Park, IPB University, current and beyond. Actually, I'm Assistant Director of Community Development Directorate, IPB University, and also I am from Mechanical and Biosystem Engineering Department, IPB University. Maybe many researchers is related to the mechanical and mechanical engineering. That's I and Pak Desriel come from. Today, I would like to introduce you our facility, actually, Agribusiness and Technology Park. Actually, ATP is part of the facility of campus IPB campus. IPB campus is consisted of Dramaga, Baranang Siang, Cilibende, and also there are several farm like Agribusiness and Technology Park, IPB University, IPB. And now I will focus on the ATP. As we know that Indonesia consisted of 17,000 islands, with the population is 270 million people. There are three kinds of cultivation in Indonesia, in my opinion. First is open field cultivation. Maybe Dr. Awang and also Professor Awang and also another presenters already present about this. And also now we still developing the indoor farming using the greenhouses and also plant factory with artificial light. This is actually our production system in Indonesia, and also consisted of plant preparation, cultivation using open field, and also indoor farming, harvesting, packaging, and sales. This activity also conducting by ATP IPB. This is the sample of the open field cultivation. If we're talking about the open field cultivation for the horticulture, and this is the indoor farming using the greenhouses. There are several plant cultivating inside the greenhouse, like in ATP IPB, we have melon, and also in another greenhouses. This is cultivation inside the greenhouses. And also we still developing the indoor farming system in IPB University. Actually, our department, Mechanical and Biosystem Engineering, also developing container base, and also ATP IPB developing a demonstration plan for the plant factory system. And this is the field facility for community development of ITP. Actually, ATP is one of the places that consisted of two places. First in Dramaga, around 6 hectares, and also in Cianjur around 2 hectares. And we have also facility of Sobatani, that this is facility for commercialization of our product, including the cafe and also including the, how to say, like a selling product from the smallholder company, our partner in IPB University. And our facility also can be used for the teaching, research, and community development. And this is the how we bring our, how to say, innovation to the market. In ATP IPB, we developing some farming system like melon inside the greenhouse, and we sell the product to the farmer. And we utilize the technology such as drone technology for spraying, but also we collaborating with the farmer to sell the product directly to the supermarket, for example. And this is our facility. Actually, we have a greenhouse from the nursery and also open field cultivation, guava. And also we have drones for the monitoring system. We already have the multispectral camera drone, including the, how to say, spraying system drones. And we also have the aquaculture production also in IPB University, and including the packing house to bring the product to the customer. And this is our new facility. We have a small plant factory with 1,000 plant, and also for Sobatani Cafe and Mart. And in the future, we would like to develop also the agriculture photovoltaic. It's mean that how to utilize the energy harvest from the photovoltaic and to give the electricity for the horticulture productions. And also in our facility, we have also the program, the community development program we call One Village, One CEO. This is how to deliver the innovation, IPB innovation. One village should have one product, and one product should have one CEO, and one innovation and one CEO, and bringing the product to the market. In this year, we are collaborating with many, how to say, like a company, like Astra company, and also Adaro company, to build the One Village, One CEO in our facility. And also we still developing some activity research for the community development, such as the how to utilize the Internet of Things for the monitoring and control of our greenhouse. Mainly our greenhouse is already implemented with the monitoring system, but in the future we would like to develop also the plant phenotyping system inside our greenhouses. And we will starting this year for the seedling, but the research already starting previously in the research step. And also environmental impact also important. That's why we also conducting some life cycle assessment activities to calculate the environmental impact of each activities in the cultivation system. And also how to improve the models of the indoor farming models, such as the how to maintain the temperature. Actually, inside the greenhouse, maybe it's difficult to maintain the temperature. We already control how much the nutrition, but it's difficult to control the environment condition inside the greenhouse. And this is our previous research about how to utilize the image processing system using the camera approaches for monitoring the Purwochen, for example, in the previous research, and also developing one integrated dosing system, for the how to deliver the nutrition to specific plant, for example. I think that is our, how to say, overview of our facility and also our previous research. If you have any question, and also in the future, of course, if we have a collaboration between the China University and also IPB University, please welcome to ATP IPB. Thank you very much. Good morning all.
Thank you very much, Dr. Supriyanto, for the excellent presentation and on time. So now I would like to open for discussion, about either Dr. Yu Wang's presentation and Dr. Supriyanto's presentation. Any question? I think this is a very nice opportunity, to go to ATP, Agribusiness and Technology Park, for either for implementing the technology or to do research together. Any question? No. Okay. If no question, then I would like to sum up our discussion for today. We are sorry that Dr. Eva has a workshop, so she asked me to make the conclusion for today's session. Okay, the conclusion is as follows. Can you see my screen? Yeah. Okay. Yeah, this one. So from our discussion and presentation, short presentation, sorry, not enough time for discussion. So from our presentation, we can probably group the researches that are related one to another. So as a matchmaking for researchers. So the first one is, if I may conclude, this is about the unmanned farm, agricultural machineries, and battery management, which can be collaborated between Professor Sudrajat, Professor Siwan Luo, Dr. Desrial, Dr. Wen Yu Zhang, and Dr. Zia Huan Lu. So this is both from IPB and also from South China Agricultural University. So I think this is quite related, what you have presented, because this is related to machineries and automation of the farm. And then the next one is about the remote sensing of paddy and rice fields. This can be collaborated between Professor Baba, Dr. Yeni, and Dr. Juan Liao. This is about, because this is all related to paddy field and rice field, how you detect the pest and the diseases. And then the last one is about the automation and precision farming of horticulture. I think this is quite related between the research from Professor Awang and the research from Dr. Yuang, and also what have been presented by Dr. Supriyanto just now, because the precision farming can be implemented, I think, in the ATP IPB. And of course, the researchers can be done there, and also the implementation of the finished product later on. So I think this is to sum up our discussion. The potential form of collaborations can be applying for collaborative research funding together, joint supervision of students, for example, joint publications. I think this is the easiest one. Joint supervision of students. And the last one is what have been presented by Professor Awang as well, student enrollment at IPB University's new international study program, Smart Agriculture. So this is open for all international students, including students from South China Agricultural University. If you are interested, you can probably have some kind of exchange program. So if any other additional discussion to be added, I would like to ask for another 3 minutes. Any additional point of view to mention?
Yes, here.
Yes, please,
One more,
Doctor.
One more comment. Because
Yes,
I think we about 2-3 months ago, we have a cooperation for palm oil machinery mechanization, a project with IPB and between IPB and together with IPB and South China Agricultural University. Maybe later we can start our collaboration in this field, the machinery for the palm oil harvesting, planting.
Yes, of course. Thank you very much, Dr. Yuang. Very nice collaboration to follow up again. Probably we have Professor Sudrajat as well, who is working on the Presi Palm. Professor, probably you can add up on this, please, Professor.
Ibu Carlisa, Ibu koordinasi Pak Iskandar itu, Bu.
Oh ya, Prof. Iskandar ada di sini juga, Prof?
Yes, we together with researching with Professor Iskandar about the oil palm mechanization.
Oil palm mechanization. Yeah. I think it's.
Bu Karlisa?
Yes, please, Professor Sudrajat. Please.
Thank you, Bu Karlisa. In IPB, Dr. Young, we have what we call a teaching farm for oil palm. So we have 60 hectare oil palm plantation in Jongkol, not far from Bogor. It's only maybe 40 kilometers from Kampus Darmaga. So and also we have a mini plant factory in Jonggol. So I think it is we can do the collaboration research with your university. Thank you very much.
We have a cooperative industry, Julong as Indonesia. This company have a very big oil palm garden in Indonesia.
Okay.
So maybe we can cooperate together for the project because Julong is very eagerly to searching for some machinery can be used in his farm.
Okay, thank you very much.
Yeah, thank you very much, Professor Derajat, Professor Baba, and also Dr. Yuang. So there's another cooperation that we can follow up with, which is the cooperation about oil palm. Yeah, both the automation and also the use of teaching factory. Yeah, for example. Thank you, Dr. Yuang. Any other discussion before we close?
Yeah, I just want to mention, Ibu Nisa.
Yes, Professor Baba.
What our partner from Southern Agriculture University mentioned. I think the group from coordination from Pak Iskandar already need to be followed as soon. Actually, Julong that mentioned just before already asked about the time for. Yeah, actually they want to visit also Jonggol as well as giving lecture actually.
Yeah, so probably we need to follow up this as soon as possible, yeah, to Professor Iskandar, yeah, Prof. Baba, yeah. Yeah, yeah, thank you, Professor. Okay, Dr. Yuang, thank you again for all the presenters and also the participants. We are sorry for the lack of time of discussion. This is still a very heated discussion, but due to the time limitation and due to the requirement of Friday prayer in Indonesia, we need to end this session. Thank you very much once again. I'm sorry as the moderator if I have mistaken words or any wrongdoings during moderating this session, and I hope we can follow up this as soon as possible. Thank you very much again. Thank you. Assalamualaikum warahmatullahi wabarakatuh.